Vocabulary: set, element, empty set, cardinality, finite, infinite. Symbols. Set is a collection of elements. Let set E3 be the first three even numbers 2, 4, 6. The vertical line means such that E3 equals 2, 4, 6, first even numbers, x such that x element of first three even numbers, x such that x minus 2, x minus 3, x minus 6 equals 0. Order and repetition of elements doesn't matter, but let's not be confusing. The ellipsis continues a pattern up to a certain end or without end. First 10 positive even numbers, positive even numbers, positive odd numbers. If something is an element of a set, then we write this. If not, then that. 2 element of even, 2 not element of odd. A set with no elements is called the empty set. Sets can contain other sets as elements. Note that internal elements of sets within sets are not elements of the external set. Elements of set S, 1, 2, set containing 1, 3, empty set, where set T equals set containing 1, 3, 3 not an element of S, although 3 element of T. We can define elements of one set based upon elements of another. Positive even numbers less than 10. Some sets have their own definitions. N, positive integers, natural numbers. W, whole numbers. Z, integers. Q, rational numbers. Q bar, irrational numbers. R, real numbers. C, complex numbers. Note that integers are positive and negative whole numbers and 0. Integers greater than 0, that is positive integers, will be Z positive. Now, if we let set odd be the set of all odd integers and E be the set of all even integers, then we could have this set of even integers, set of odd integers. The cardinality of a set S is the number of elements in that set, and we use the absolute value to find that number. Where T equals set containing 1, 3, where S equals the set containing 1, 2, T, empty set, empty set. A set is finite if its cardinality is a non-negative integer. An infinite set is one that is not finite. Vocabulary: subset, equal, unequal, proper subset, universal set, power set, intervals. Symbols: a set A is a subset of a set B if every element of A belongs to B. If A has an element that is not in B, then A is not a subset of B. two sets A and B are equal when they contain exactly the same elements. These sets would be subsets of each other, A subset of B and B subset of A. When there is some element belonging to one set but not the other, then the sets are unequal. A set A is a proper subset of a set B when A subset B, but A does not equal B. Consider the proper subsets of the real numbers. Note the following. The universal set U is the largest set that we're considering, and it varies depending on the context. The power set of A is the set of all subsets of a given set A, and is noted by this. Regarding subset, note that every set is a subset of itself. The empty set is a subset of every set. Consider set A, its subsets, and the power set of A. Here, the subsets of A would be the following. So, the power set of A is the following. Later, we'll learn that if A is a finite set with n elements, then cardinality of power set of A equals 2 to the power of cardinality of A equals 2 to the power n. In our example, cardinality of A equals 2, and so cardinality of the power set of A equals 2 to the power of 2 equals 4. Consider set B, its subsets, and the power set of B. Here, the subsets of B would be the following. So the power set of B is this. Regarding sets, note that empty set not equal to set containing empty set, not equal to set containing the set containing the empty set. Regarding elements, note that empty set element of B and set containing the empty set element of B, but set containing the empty set not element of B, although set containing the empty set element of power set of B. Some subsets of R are called intervals. For A be element of R and A less than B, unless stated otherwise, we have the following. Open, closed, half open, singleton. In terms of subsets, note that for A less than B, then this. Sets could be on infinite intervals. Infinity is not a real number and is denoted as infinity sign. Where A element of real numbers, we have the following. Vocabulary: union, intersection, disjoint, difference, complement, relative complement. Symbols: the union of two sets A and B is a set of all elements belonging to A or B. That is, element X could be in A only, B only, or in both A and B. Here, the intersection of two sets A and B is the set of all elements belonging to both A and B. Here, two sets A and B are disjoint when no elements are common. Here, note that rational numbers union irrational numbers is real numbers, and rational numbers intersection irrational numbers is empty set. Also note that even numbers union odd numbers is integers, and even numbers intersection odd numbers is empty set. The difference of two sets A and B is defined as x such that x element of A and x not element of B. When all sets are subsets of a certain universal set U, the complement of a set A is this. Our notation for irrationals is based upon complements with U equals real numbers. Here. Note that A subtract B could be called the relative complement of B in A. Here. X such that X element of A and X not element of B. Vocabulary: union, intersection, index set, index collection of set. Symbols: the union and intersection of n greater than or equal to 2 sets A1, A2, and so on, AN, are this and that. Consider the sets A1, A2, and so on, AN. For A element of union I equals 1 to n, AI, the element A belongs to at least one of the sets. For A element of intersection I equals 1 to n, AI, the element A belongs to all of the sets. When we want to consider certain select sets, the non-empty index set I is used. The index collection of sets is the collection of all sets S alpha, where alpha element of I. The notation is the following. For the collection here, its union and intersection are this and that. Consider the sets in the collection here. For A element of union alpha element of I, S alpha, the elements A belong to at least one of the sets. For A element of intersection alpha element of I, S alpha, the element A belongs to all the sets. Note the union here. We can write union n element of positive integers, AN. For our example, for each n element of positive integer, let AN be the closed interval here. And so AN equals this. Explicitly, we have A1 equals inclusive negative 1 to 1, A2 equals inclusive negative half to half, A3 equals inclusive negative 1/3 to 1/3. For every n element of positive integer, note that this and so union n element of positive integer an equals inclusive -1 to 1. 0 element of an, and in fact, intersection n element of positive integer an equals singleton of 0. Vocabulary: pairwise disjoint, partition. A collection S of subsets of set A is called pairwise disjoint if every two distinct subsets that belong to S are disjoint. A partition of set A is a collection S of subsets of A where non-empty sets X not equal to empty set for every set X element of S, pairwise disjoint sets for every two sets XY element of S, either X equals Y or X intersection Y equals empty set. Union of all subsets in S is A. Union X element of S, X equals A. The integers can be partitioned into the evens and odds. The real numbers are can be partitioned into the positive and the singleton of 0 and the negatives. The real numbers R can also be partitioned into the rational numbers Q and the irrational numbers Q bar. Vocabulary: ordered pair, Cartesian product. Symbols: an ordered pair xy is a single element that consists of a pair of elements where x is the first element or first coordinate of the ordered pair, and y is the second element or second coordinate of the ordered pair. When two ordered pairs xy and wz have x equals w and y equals z, then those ordered pairs are equal, as follows. The Cartesian product, or simply product A cross B of two sets A and B, is a set consisting of all ordered pairs whose first coordinate belongs to A and whose second coordinate belongs to B, as follows. Regarding cardinality, for all finite sets A and B, cardinality A cross B equals cardinality A times cardinality B. From this, note that if either A equals empty set or B equals empty set, then A cross B equals empty set. The Cartesian product R cross R is the set of all points in the Euclidean plane. The graph of y equals f of x is the following set here.